back to my channel. This is Pragya Jain, and today in this video we are discussing a topic of model evaluation. So the key objective of this video is to discuss the techniques for accessing and improving machine learning model performance using Python. So let's discuss about the basic definition of what is model evaluation and learn what is model evaluation. So first, the model evaluation is the process of using different evaluation models to understand a machine learning model as well as the strength and weakness of a particular model. This process is very useful in the earlier times of research phase, and it also plays a role in model monitoring. The key objective of this model evaluation is to accessing the accuracy and reliability of machine learning models. So we have a splitting data, trained validation, and a test sets. We have three sets. We'll discuss these one by one. First, a training set. It is used to train the model, learning patterns, and the relationships within it. Second one, we have a validation set. It is used to tune model hyperparameters and select the best model configuration. The third one, we have a test set. It is used to evaluate the final model performance on the unseen data. So we have a training set, then comes a validation set, then we have a test set for measuring the performance of a model. Now we are discussing about the evaluation matrix for the regression model. In regression model, we have three terms that mainly discussed for evaluating a model. The first one, we have the mean square error. The second one, we have root mean square error, and the third one we have R square. In mean square error, it measures the average between the predicted and the actual value. In root mean square error, it is the root of the mean square error, and it provides an average error for original units. The third one we have R square. It indicates the proportion of variance in the dependent variable explained by the model, and the range is between from 0 to 1. Now we have evaluation matrix for classification model. Here we have accuracy, precision, recall, and F1 square. We'll discuss all of them one by one. First one we'll take is accuracy. It is the ratio of classified instance of the total number of instance. The second one we have precision. Precision is the measure of how many of the predicted positive integers are actual positive. The second one we have is recall, measure of how many of the actual positive instance are correctly identified. The fourth one we have is F1 square, is a harmonic mean of precision and recall, and providing a balanced measure of the model performance. By all of these four metrics, you can classify a model performance on basis of what are the weakness and strengths of a particular model. So now we have visualizing model performance. It is the confusion matrix, the receiver operating characteristics, and the precision recall curve. First one we'll discuss about the confusion matrix. It is a visual representation of model performance on a classification task. Next one we have a receiver operating characteristics curve, that is ROC. It plots the true positive on the x-axis and the false positive rate on the y-axis, and represent a curve for classification thresholds. The third one we have is precision recall curve. It illustrates the trade-off between the precision and the recall for different model thresholds. Now we'll discuss about the coding part, that is evaluating a linear regression model. So here we are using Python for this coding part, and first one we are importing some libraries, and therefore using them and making our coding more easier. So first we have import the linear regression, trained test split, mean square error, R2 square. So in this code we are load and split the data, train the model, make predictions, and evaluate the performance, and finally print the desirable values for evaluating. So here we are in load and split data, we are initializing the variables like x trained, x test, y trained, y test is initializing to the value of test size 0.2. Now we are training the model Here the linear regression is the function we are using to train the model, and we are making the predictions using the model.predict x test. Then we are evaluating the performance using two methods, that is the mean square error and R2 score. Then we are printing the value of mean square error and R square. So this is about the linear regression model. Now we are using another model, that is a logistic regression model. So same here, we are importing libraries like logistic regression, train test split, accuracy score, precision score, recall score, F1 score, confusion matrix. So here we are loading the split test, is loading and split the data, train the data model, make predictions, evaluate the performance, and finally printing the values. We are initializing the variables, then training the model using a function called logistic regressions, then make predictions using model.predict, then evaluating the performance using 5 parameters called they are accuracy, precision, recall, F1 and CM. And here we are evaluating the performance of the model and then printing this value. With the help of this value, you can tell about the weakness and the strengths of a particular model and what are the predictions and the actual data and the difference between them. So the conclusion about this whole video is to understand the data by pre-processing it and exploring about more for making it a successful model evaluation. The second one, we have choose the right matrix. We have number of matrix. You have to choose the right one for your particular model according to your needs and evaluations. The third one we have is visual performance. In visual performance, you need to use the techniques of visualization to gain insights and identify areas for improvement. So that is it for this video. See you again for the next video. Stay tuned. Thank you.